Okay, let's talk about some Lewis dot structures. So here are our objective and essential question for today. I encourage you all to pause the video and write these down in your notes. Feel free to pause or rewind anytime you need to get the information you would like to write in your notes. As a reminder, if you see this little icon on the slide, you should pay extra attention and make sure to record whatever is on that slide in your notes. So our objective will be to draw 3D and 2D Lewis dot structures based off of molecular formulas. And our essential question is, how do we use Lewis dot structures to represent molecules in real life? So Lewis dot structures are really important for our understanding of organic molecules and how organic molecules can be used in medicine. So as a reminder, we have different types of chemical bonds, one of which is called a covalent bond. So a covalent bond happens when valence electrons are shared between two atoms. Keep in mind that different elements on the periodic table like to have a certain number of valence electrons. Typically, those elements like to have 8 valence electrons, so we represent those valence electrons as dots. So here is carbon with its octet filled. But certain elements like hydrogen only really like to have 2 electrons in their valence shell. And you can count the number of valence electrons an atom has by counting the number of boxes across its row or its period of the periodic table. So this is what a single covalent bond looks like. However, we typically represent this by a line in a Lewis dot structure. So while this is a correct representation, we typically, for a bit of an easier method, is to simply represent that with a line. And we have the understanding that this is what is actually going on in that covalent bond. Those 2 electrons are being shared between those 2 atoms. Now we could also have double bonds. So for example, we could have a carbon sharing 4 electrons with an oxygen. Oxygen is another atom that likes to have 8 valence electrons. So in reality, in our Lewis dot structures, we typically represent that with 2 dashes. We could also have triple bonds, which is when 6 valence electrons are shared between 2 atoms, and we would represent that with 3 lines, like so. Again, just as a reminder, at any point, please do pause your video to record this in your notes before moving on. So these are the steps that we use to draw Lewis dot structures. Now, again, I encourage you all to pause your video and write all of these down in your notes as we go through each one by one. So the first step is to count all valence electrons in the compound. So in this case, we have ammonia, which is made up of 1 nitrogen and 3 hydrogen atoms. So 1 nitrogen atom, if we were to look at the periodic table and count its valence electrons, you would see that it has 5 valence electrons. And I'm going to use E minus to represent an electron. We have 3 hydrogen atoms. So each hydrogen atom on the periodic table actually only has 1 valence electron. But since we have 3 of them, we actually are going to have 3 valence electrons from those hydrogens. So in total, 5 plus 3 is going to be 8 valence electrons in our compound of ammonia. Now, our second step is to determine the central atom. So the central atom is typically, a good rule of thumb, the one that we only have one of. So in this case, we only have one nitrogen. That's going to be our central atom. In future Lewis dot structure drawings, you will actually see Lewis dot structure drawings with more than one central atom. But for now, we're going to go with it is the one atom that we only have one of. So now that we've determined our central atom, we are going to draw all other atoms around the central atom and draw single bonds to this central atom, connecting those outer atoms to the central atom. So I'm going to draw my central atom here. And then I'm going to draw my other atoms around my central atom. So my other atoms are simply my 3 hydrogen atoms. And then I'm going to draw single bonds connecting those outer atoms to my central atom. Finally, in step number 4, we're going to put all remaining electrons as lone pairs or double or triple bonds to satisfy the octet rule or the duet rule for hydrogen and helium. So in this case, our hydrogens are satisfied. So we've got 2 valence electrons. Remember, each line represents 2 electrons. So this hydrogen has 2 electrons. This hydrogen has 2 electrons. I'll draw these here as well so you can see them. And this third hydrogen has 2 electrons. Our hydrogens are satisfied. Now the only thing that is left is to double check and make sure that our nitrogen is satisfied. So if I count up these electrons for nitrogen, 1, 2, 3, 4, 5, 6, I see that it in fact only has 6 valence electrons. So I'm going to add 2 more lone pairs to nitrogen, and that gives me a total of, or it completes its octet. Now, if I want to check my work, I'm going to count the electrons in the lone pairs and the electrons in the bonds to make sure they add up to 8. So in each bond, I have 2 valence electrons. So I have 6, 2, 4, 6. And then in my lone pair, I have an additional 2 electrons. So I have 8 valence electrons in this in this compound. And that matches up with the 8 valence electrons I determined it already needed in my first step. So that is one example of how to draw Lewis dot structures. Now let's talk about how we might draw the 3D version of the Lewis dot structure we just created. So I'm going to redraw this on screen. Now the key is to actually we're going to use this diagram to count the lone pairs and the number of atoms coming off the central atom to determine its 3D structure. So if I were to count the number of lone pairs in this Lewis structure, I see that it has 2 lone pairs. It has 1 lone pair. And I see that it has 3 atoms sticking out of it. So 3 other outer atoms. And we call this the steric number. Okay, so I have 3 outer atoms and 1 lone pair. So what that means is I am looking for 4 things sticking out. So 3 plus 1 is 4. That is our steric number. All right, number for short. So if I look in my rows here for my steric number, I'm going to look for 4, and here it is. And then I'm going to look for at the top of each column how many lone pairs I have. And I see that ammonia only has 1 lone pair. So I'm going to drag across my eyes across the screen, and I should be looking at this 3D structure here. So if I want to redraw ammonia in 3D, I'm going to draw my central atom. I'm going to kind of mimic this structure here. So I'm going to draw my lone pairs on top of the nitrogen. And then I'm going to draw 1 hydrogen atom, what we call in the plane of the screen. So this basically means that this is a 2D form right now. Now, I see that I also have 2 other hydrogens. So 1 hydrogen is going to come out of the plane of the screen. So we represent that with a wedge to indicate that it is coming out towards you right now. And our last hydrogen is going to be going into the plane of the screen. So it looks like it's going away from you. And we represent that with a dash. So that is how we draw ammonia in 3D form. And if you look at the actual 3D structure of ammonia, you can see that it mimics our 3D drawing pretty well. Okay, we will go over one more, slightly more challenging problem for drawing one more Lewis dot